are going to discuss about a simple problem. 4 parallel forces of magnitude 100 Newton, 150 Newton, 25 Newton and 200 Newton are shown in the figure. Determine the magnitude of the resultant and also the distance of the resultant from point A. This problem is similar to what we discussed in our previous videos. So 100 Newton is acting upward, 150 Newton is acting downward and 25 Newton is acting downward and 200 Newton is acting upward at A, B, C, D respectively. They given the distance between A, B, B, C and C, D, right. So now we have to find the resultant first. So resultant R, which is equal to upward force minus downward force. Let us take, so downward force is minus and upward force is positive. So 100 Newton is positive plus minus downward 150 and minus 25 and plus 200 Newton. So R, which is equal to 100 plus 200, 300 minus 175. So which is equal to 300 minus 175, 125, right. So value of R, the resultant, magnitude of resultant, which is equal to 125 Newton, right. So now let us assume this resultant R is acting somewhere, right, in between CD or AB, whatever it may be, and this is positive value. So we assume that positive value is acting upward and the force acting downward, which is negative. So this is positive we got. So this force is acting upward. So this is resultant acting upward, right. So now let us assume the distance between A and F, which is equal to x, right. So now take moment about point F. Now take moment about point F. So 100 Newton and 100 Newton is acting with respect to F, which is the clockwise direction, and 150 and 25 are acting downward, which means with respect to F, this 150 and 25 are acting anti-clockwise direction, right. So with respect to point F, this 200 Newton is acting anti-clockwise direction, right, and 100 Newton is clockwise. So that's why 100 into x, so minus 150, second point, right, 150 into x minus 0.9, the distance between B and F, which is equal to x minus 0.9, and 25 Newton is also downward. That's why 25 into x minus sum of these two distance, right. So 0.9 plus 1.2, clear, which is equal to D point is acting upward. That's why 200 into sum of all. So 0.9 plus 1.2 plus 0.75 minus x, right. So simplify this, which is equal to 125 x, which is equal to 570 minus 135 minus 52.5. So x, which is equal to 379.5 divided by 125, which is equal to 3.036 meter. So the resultant R is acting upward at a point or at a distance 3.036 meter from A, right, 3.06 meter from A, and R, which is equal to 125 Newton, right. Next problem, it's a very simple problem. A machine component 1.5 meter long and weight 100 Newton is supported by two ropes AB and CD, right, as shown in the figure given below, and we have to find the tension. We have to find the tension in the rope, right. So T1 and T2 we have to find. So find T1 and T2, right, tension in the rope we have to find. So now we know that the weight of they given a component of 1.5 meter long length and the weight which is equal to 1000 Newton. So normally the weight is acting downward from CG, right. So 1000 Newton, clear. Now we know that already the force is, whenever the force is acting with some inclination, we have to resolve these forces into two components. One is horizontal component, another one is vertical component, right? So here the rope AB and CD both are is an inclined position with 60-degree inclination and 45-degree inclination. So we have to resolve this two inclined forces into two components. One is horizontal and vertical, and another one is horizontal and vertical for CD rope, right? So resolving the forces, resolving the forces horizontally, right? So this force is divided into two. This is inclined force with respect to 60-degree, right, horizontally. So tension T1 is acting this side. Similarly here with respect to horizontal, so this is T2 and the inclination which is equal to 45-degree, right? So draw a line, vertical line. So this is upward. Similarly draw a line, this is upward, right? So opposite force which is equal to T2 sine 45-degree. Similarly here opposite force T1 sine 60-degree. Similarly horizontal force acting this side, so this is T1 cos 60-degree. Similarly the horizontal force is acting this side, so this is T2 cos 45-degree, right? So now resolving the forces horizontally, so we have to take this horizontal forces, both are opposite sides, right? So arrow mark towards left side and here the arrow marks towards right side, right? So now T1 cos 60-degree which is equal to T2 cos 45-degree, right? So now T1 which is equal to T2 cos 45-degree divided by cos 60-degree, which is equal to 1.414 T2. So now we got the equation T1 which is equal to 1.414 T2. So this is the equation we got first, right? So now resolve the forces vertically. So resolve the forces vertically. Okay, resolve the forces vertically. So now consider this T1 sin 60 and T2 45, and one more force W is acting downward. These two forces T1 and T2 is acting upward and W is acting downward. So downward force which is equal to upward force, right? So now here downward force which is equal to 1000, which is equal to T1 sin 60-degree plus T2 sin 45-degree, right? So we know that T1 which is equal to 1.414 T2, substitute T1 value in terms of T2, 1.414 T2 sin 60-degree with plus T2 sin 45-degree, right, which is equal to 1000. So now simplify this, then we got T2 which is equal to 518.1 Newton, right? So this is the value we got for T2. Now substitute this T2 value in this equation, then you will get T1. So T1 which is equal to 1.414 into 518.1 Newton. So T1 which is equal to 732.6 Newton, right? So this is how we have to solve this problem, T1 and T2, clear, right? So T1 which is equal to 732 Newton and T2 which is equal to 518 Newton, right? See, 732 and 518, okay. So now next problem, a triangle ABC has its side AB 40 centimeter long along positive x-axis and side BC 30 mm long along positive y-axis. Three forces of 14 Newton, 15 Newton and 13 Newton act along the sides of AB, BC and CA respectively. Determine the magnitude of the resultant of such a forces. So this is the problem. So 40 Newton is acting along the x axis and 50 Newton is acting along the y axis, right? I mean 30 mm. 30 mm is along x axis and 40 mm along x axis. So 40 mm along x axis, 30 mm along y axis, and three forces. 40 belongs to 40 mm and 50 belongs to 30 mm and 30, right, is acting as a third force. So theta here. So first we have to find theta. So we know that this is opposite side and this is adjacent side, right? So tan theta, which is equal to opposite by adjacent. So theta, which is equal to how much? Theta, which is equal to 30, tan inverse of 30 divided by 40. So which is equal to 1 minute, tan inverse of 30 divided by 40, 36.86. So theta, which is equal to 36.86 degree, right? Clear? So now, so we have to resolve this. See, whatever may be the forces acting at an inclined position, we have to resolve into two forces. One is horizontal, another one is vertical. So this 30 Newton is inclined 36.86 degree with respect to horizontal axis. So this AC is divided into two component. One is vertical component, another one is horizontal component, right? So this is vertical component, this is horizontal component, right? So horizontal component, which is cos, 13 Newton cos 36.86, and vertical, which is equal to 30 sin 36.86 degree, right? So now for horizontal, both are opposite direction, this one and this one, right? So 40 Newton. So let us first solve sum of horizontal forces, which is equal to 0. So horizontal forces, how many horizontal forces here? 40 Newton is acting horizontally towards right side, and 30 into cos 36.86 is acting towards left side. So both are equal, right? 30 cos 36.86 degree, which is equal to 40, right? Determine the magnitude of the resultant, right? So now, so here sum of horizontal forces, which is equal to 40 minus 30 cos 36.86 degree, right? So which is equal to 40 minus 30 into cos 36.86, which is equal to 0.8, which is equal to 16 Newton. This is horizontal force, right? So now resolve vertical forces, right? So vertical force, now resolve vertical forces, right? So which is equal to sum of vertical force, which is equal to, how many vertical forces are there here? 15 Newton is acting upward and 30 sin 36.86 is acting downward, right? So now upward force, which is equal downward. So let us take upward, which is equal to positive value, 50 minus downward is negative. So 30 sin 36.86 degree. So which is equal to 50 minus 30 into sin 36.86, which is equal to 0.6, which is equal to 32 Newton, right? So now we know that the resultant, which is equal to root of horizontal, sum of horizontal squared plus sum of vertical squared, we know that, right? So which is equal to root of 16 Newton squared plus 32 Newton squared. So which is equal to R, which is equal to 35.8 Newton. So this is the value we got, R, right? Yes, 35.8, right? 35.8 Newton. Clear? Thank you.